Hello everyone, welcome to the class on circuits and networks. So today again we are going to solve problems related to maximum power transfer theorem. So again we are still dealing with the DC circuits and we can just check out the problem. So in this problem we have to find out the value of RL such that maximum power is being transferred, and you also have to find out the value of maximum power transferred. So how can you do that? So as mentioned, the first step is to find out the value of RTH, because maximum power transfer theorem states that the maximum power is transferred when RS is equal to RL, or sorry, as we should say in proper terms, RL is equal to RS. And how can you find out the value of RS? So RS can be found out simply by finding out the Thevenin's equivalent resistance. So RS is equal to RTH. So as the first step, we are going to find out the value of RTH. In order to find out RTH, we are going to remove the load resistance and we will deactivate the constant sources. So in this case, you can see there are three constant sources over here. So we are going to deactivate the sources. So deactivating the sources would mean short circuiting the voltage source and open circuiting the current source. So we can just redraw the circuit over here. So I'm just going to redraw the circuit. So first and foremost, I'm going to remove the load resistance. So the voltage source has been short circuited. There was a current source over here. We have open circuited the current source. And again this 10 volt has been short circuited. I'll just write down the values. Now, so our first step is to find out the value of RTH. Now we simply have to find out the value of the equivalent resistance to find out RTH. So I'm just going to give these terminals the names A and B. And over here, what is going to happen is that you can see that the terminals A and B are present in between. So as I previously mentioned, it's always better to place the terminals on one side. So I have the terminals A and B over here, and you can see that the terminal A is splitting into 1 ohm and 5 ohm. So you have 1 ohm over here, and you can see the 5 ohms, they both are connected in series. So I have one 5 ohm and another 5 ohm. So 5 ohm and 1 ohm, and the 1 ohm is connected back to the B terminal. So I am going to connect it back to the B terminal, and from the 5 ohm we are having it back to the B terminal. Now you try to find out the value of RTH. So now you can see it is more clear over here. These two 5 ohms, they are in series, so you have a 10 ohm, and this 10 ohm and 1 ohm, they are connected in parallel. So you are having a 10 parallel 1 ohm over here. So that will be the value of RTH. So if you are just solving for the value of RTH, you will get it as 0.91 ohms. So that would be the value of RTH. So our next step, step 2, is to simply find out what is the value of the load resistance. So step 2 is you need to find out RL, and we know that RL is equal to the source resistance, which is equal to RTH, which is equal to 0.91 ohms. So that is your load resistance. And the next step would be again to find out the value of VTH. So I'll just take the next page. So my next step is to find out VTH. How can you find out VTH? So I'll just redraw the circuit. Now if you're redrawing the circuit, please you just check the previous figure over here. Now, to find out the value of VTH, we have to remove the load resistance. Remove the load resistance and find out the voltage across the open circuited terminals. Okay, so I'm just going to redraw the circuit over here without the load resistance. So I am redrawing the circuit. So you have a 5 ohm over here and a 10 volt over here, and this is 4 amperes. So you have 5 ohm, 1 ohm, 8 volt. Okay, so my figure is complete, and I am going to mark my VTH over here. So now you just try to look at this particular figure and see how many loops are there. Okay, so in order to find out VTH, always the first step that we do is to apply the mesh analysis, and you just look at the figure over here. You can see that there are two meshes in this circuit. Okay, so this is my first mesh, that's my mesh 1, and you can see here this is my mesh 2. Now when I'm starting to write my mesh equations, I can see that there is a current source in between. Okay, you can see that over here. I'll just mark it. So you can see that there is a current source in between the two meshes. Okay, if a current source is present only in one mesh, then the value of the mesh current will be equal to the current source value. But over here, oh sorry, this is not 4 volt, it's actually 4 amperes. I'll just make the correction. Okay, I hope. Oh yeah, it's 4 amperes. Okay, so as I was mentioning, if the current source is present between the two meshes, then in that case what happens is that you have to use the concept of super mesh. Okay, you cannot do the normal mesh analysis, you need to carry out the super mesh analysis. And how can you do the super mesh analysis? So what you're going to do is that you're going to check out the two meshes where the current source is present. So the current source in this case, it is present in the meshes 1 and 2. So I'm just going to combine these two meshes. So I'm just combining it over here. So now this is my super mesh. Okay, the dotted lines are representing my super mesh. So always make sure that your super mesh is having both the currents in the same direction. Okay, try to make sure that the super mesh contains the both the currents in the same direction. It's not necessary, but I think it will help to avoid mistakes. And I'm going to write the equation for super mesh. So you're having the 8 volt over here, so that will be plus 8. Then you have the 1 ohm over here, so it is minus 1 into the current over here is I1. 1 into I1 minus, so you have 5 ohm and the current is I1, so 5 into I1. Then you are having again a 5 ohm over here, but the current through this 5 ohm is I2. So you will write it as minus 5 I2. Then you are having a voltage source, so it is going from plus to minus. So you have minus 10 is equal to 0. So I'll just rearrange it. Minus 6 I1 minus 5 I2 will be equal to 2. So that's my first equation. Next, along with the super mesh equation, you need to write the current equation. Okay, along with the super mesh equation, instead of two mesh equations, mesh 1 and mesh 2, here you are having the super mesh equation and the current equation. And how can you write the current equation? So in order to write the current equation, we are going to use this branch. Okay, so we are having a 4 ampere over here. So 4 ampere is equal to, see, the 4 ampere is present between the two meshes I1 and I2. Okay, among that you can see, so obviously 4 amperes will be the difference of I1 and I2. Either it can be I1 minus I2 or it can be I2 minus I1. And how can you decide which one it is? Whether it is I1 minus I2 or I2 minus I1. How can you decide that? Okay, so in order to decide this particular case, what you're going to do is that you're going to look at the directions of I2 and I1. So you can see I1 is going in the downward direction compared to the 4 ampere, whereas I2 is going in the upward direction. So you can see that I2 is in the same direction as 4 ampere. So you can write it as I2 minus I1. So you can solve both the equations. Now again, the mistake that you make over here is that, see over here it is I2 minus I1. And for the first equation, your order is I1 and then I2. So it's always better you rewrite this equation. So I'm just rewriting the equation over here. So I'm just taking this, I'm just rewriting. So it will be minus I1 plus I2 is equal to 4. So I'm going to take this as my second equation. And once you are solving for both of the equations, you will get the values of I1 and I2. So I have just solved it out over here. I'll just check the solved answers. Alright, so you're going to get I1 is equal to minus 2 amperes and I2 is equal to 2 ampere. Okay, so I'll just rub off all the unwanted parts over here. Okay, right, I'll just remove some. Why I'm going to remove all of this is we had drawn all of this to mark the super mesh. Now we need to find out the value of VTH. Okay, so for that I'm just removing these parts. Okay, and I'll just come back to the other color. I'll just mark I1 over here. Okay, so once you have completed the mesh, you need to find out the value of VTH. So as I have already mentioned, in order to find out VTH, you just go from the positive to negative. You take the smallest path. Okay, so the smallest path over here would be either I can go like this, but you can see over here if I'm following this path. So again, I think I'll take another color. Right, if I'm trying to go like this, obviously I don't know what is the voltage across a current source. So what I'll have to do, I'll have to go like this, and you can see this path is a bit more bigger. Okay, so what I'm going to do is that I'm going to take the shorter path. So you can see this is the shorter path. Okay, and again when you need to find out VTH, you need to write down the, or you need to mark the polarity of resistors. Okay, the polarity of voltage sources you need not mark them, but if there are any resistors you need to mark the polarity. So what will be the polarity of this resistor? Okay, the current flowing through the 1 ohm is I1, right? And you can see I1 is flowing like this, right? So that means if I1 has to flow like this, the voltage induced will be plus at the bottom and minus at the top. So this is going to be your polarity, and again we are going to check this path like this. So you can see from the positive is going to the negative of the resistor. So I can say VTH is equal to minus the voltage across 1 ohm. And what about the voltage source? So you can see from the positive it is connected directly to the positive of the 8 volt. So I can say plus 8. So minus the voltage across 1 ohm plus 8 will give you VTH. And how can you find out the voltage across 1 ohm? So if you need to find out the voltage, always V is equal to I into R. So the current flowing through the 1 ohm is I1. So 1 into I1 plus 8 will give you VTH. So that means it will be I1 is minus 2. So you minus of minus will be plus 2 plus 8. You will get VTH is equal to 10 volt. So you have got the value of VTH. And finally, our next step will be to draw the Thevenin's equivalent circuit and find out the amount of power dissipated in the circuit. So I've got VTH is equal to 10 and RL is equal to 0.91. RTH is also equal to 0.91. So I'm going to write the last step. So as the last step, I have step 4. I'm going to draw the Thevenin's equivalent circuit. So this is my Thevenin's equivalent circuit. I have VTH is equal to 10 volt and I have RS or RTH is equal to 0.91 ohm, and I have RTH is, or sorry, not RTH, it's actually RL. RL is equal to 0.91 ohm. And from this you can find out the current IL. So the value of IL would be VTH divided by RS plus RL. So that will be 10 divided by 0.91 plus 0.91, and you will get the value of the current. But I think the value of the load current has not been asked. So if you want, you can solve it. To find out the maximum power transferred, you can simply use the equation VTH square divided by 4 into RTH. So that will be 10 square divided by 4 into 0.91, and you get the value as 27.47 watt. Okay, so actually over here they have not asked us to find out the value of load current, so that step is not required. You can simply find out the maximum power transferred using VTH square divided by 4 into RTH. So I hope again solving one more problem has made the maximum power transfer theorem a bit more easier. So always the first step is to find out the value of RTH. Then you find out the value of the load resistance. Load resistance is equal to the value of RTH, and then you can find out VTH by the normal method. And if they have asked to find out the value of the maximum power, you draw the Thevenin's equivalent circuit and finally find out the maximum power transferred using the equation VTH square divided by 4 into RTH. So this is the final answer, and as your homework I want you to solve this particular problem. Again, you have to find out the value of RL for maximum power to be transferred. Not only find out the value of RL, but also find out the maximum value of the maximum power. And you can see that the answers are already provided over here, so that you can cross check your answers. Okay, so I hope this video was useful. Thank you.